Hello, I'm Sarah Grossarth, a pre-med biochemistry student, and for the past 2 years, I've been working on synthesizing a new, never-before-reported series of compounds that have anti-cancer activity. For the next few minutes, our team will show you what we've been up to in our laboratories. I've synthesized 4 new chemical compounds that we utilized in this study as drug candidates for potential chemotherapy. The compounds are based on the acetylpyrazine tert-butyl thiosemicarbazone ligand, but 3 of the compounds are centered on the transition metals copper, palladium, and platinum. The synthesis of these compounds is demonstrated by color changes when they are prepared. The copper complex is green, but the palladium and platinum complexes are reddish-orange. Once purified, these 4 drugs are analyzed by mass spectrometry with dilute solutions. The mass spectrum shows the molecular ions for these drugs, but in this case, they are negatively charged anions, and the molecular ions give crucial evidence that the compounds have the structures we intended them to have.
Hi, I'm Jessica Hill, a graduate student in biochemistry. I've been using nuclear magnetic resonance spectroscopy to elucidate the structures of our new compounds. Our new 500 megahertz NMR was purchased through a National Science Foundation grant, and this instrument is powerful enough for us to hear the radio frequency resonances of the individual nuclei in the molecules. The NMR spectrum of a molecule helps us to confirm the molecular structures of the new drugs. The compounds have to be individually dissolved in a deuterated dimethyl sulfoxide solvent and then placed in a small tube. Once equipped with a spinning rotor, the sample tube is inserted into the spectrometer. Within minutes, we see signals that correspond to every hydrogen atom and carbon atom in the new drug.
Hi, I'm Sarah Bowman, a grad student in biochemistry, and I have been working on determining the biological activities of our new compounds. The first tests with a panel of microbes showed that the compounds significantly inhibited growth of gram-positive bacteria. The focus of my research is on the topoisomerase 2-alpha enzyme, which we call TOPO, and this enzyme is absolutely essential for cell replication. When Sarah gives me the compounds, I first prepare a gel, and then using plasmid supercoiled DNA, I run a topo assay that shows whether the drugs inhibit the topo-mediated relaxation of the DNA. What I've discovered is that the metal-containing drugs inhibit the topoisomerase enzyme. If these compounds exhibit anti-cancer activity, this may be the reason. I have to check breast cancer cells with a microscope to determine if they live and thrive in the media for the study. Next, I place cells into the well plate, introduce the drugs, and a fluorescent agent called Alamar Blue that fluoresces when the cells are viable. I check the cell viability and determine if the breast cancer cells live when exposed to various concentrations of the new drugs.